In problems 6 through 8, we are given the test statistic and we need to find the p-value based on that test statistic. And then we're going to draw a conclusion about the null hypothesis. So let's take a look at number 6. We're told that the test statistic in a right tail test is z equals 0.52. So I'm going to start by sketching the distribution, and we are marking off where z is equal to 0.52, and this is a right tail test, so we need to find the area in the right hand tail. And how I find the area in the tail based on a z value is I'm going to use the normal CDF function, and 0.52 is my left boundary. Infinity is my right boundary, so I put in 1e99, and my mean is 0, standard deviation is 1. When I calculate that, I get 0.3015. So this is my p-value, and I'm going to compare that to alpha, which is 0.05. Since p is larger than alpha in this case, we fail to reject the null hypothesis. And so my answer would be B. Let's take a look at problem 7. Here we have the test statistic in a left tail test. So again, I draw my distribution. Doesn't have to be beautiful. My test statistic is negative 1.83. And my area is in the left-hand tail, so I'll find my p-value by calculating normal CDF. And my left boundary is negative infinity, negative 1e99 on the calculator. Right-hand boundary is negative 1.83, and the mean is 0 and 1. And this is going to give me 0.0336. In this case, my p-value is less than alpha equals 0.05, so we will reject the null hypothesis. Finally, we have number 8, and we're finding the p-value given the test statistic in a two-tail test. So this is going to work a little bit differently. Here I have my test statistic is negative 1.95, but for a two-tail test, because I have to have two tails, so I'm going to mark positive 1.95 on the right-hand side and shade in that tail as well. So my p-value is going to be all the area in the two tails. And the easiest way to find this, for me anyway, is to calculate the area in the center, find this area, and then subtract that from 1. So I'm going to do 1 minus normal CDF, negative 1.95 to positive 1.95, and then of course 0 and 1. And when I put this into the calculator, I get 0.0512, which is just a little bit greater than alpha equals 0.05. But as long as p is greater than alpha, we fail to reject the null hypothesis. And that's how you do those problems.